Okay, in this video, I'm going to show you how the human eye sees the image of the object in the water and perceive it to be shallower than it really is. So this will also help you to explain why swimming pools that are deep appear shallow instead. So in this diagram, what I have is a tiny object in the middle of a container of water. And I'll show you how the eye sees the image. Now note that the diagrams drawn in this illustration are not drawn to scale. But for illustration purpose, I'll try to draw them as close to accuracy as I can. Now, when the light strikes the object and reflects off the object, when the light reflects off the object, it strikes the surface of the water. Okay, it strikes the surface of the water, right? But I'm going to draw the second ray. So, when light leaves the water and enters air, is moving from an optically denser medium to an optically less dense medium. So from optically denser to optically less dense, the light ray eventually bends away from the normal. And this is how we're going to illustrate bends away from the normal. So it bends away from the normal. And as I say in all my lessons, when you draw diagrams like this, especially when it involves a boundary, you definitely have to draw the normal. Whether you need it or not is irrelevant at this point. It is always a good habit to draw the normal because you might not know when you're going to need it. Okay, the other is drawn grossly out of scale. I will redraw again. Right. So it bends away, okay? And your eye is here. It's going to look strange, but never mind. So be it. This is your eye. Sorry, can do better than that. This is a side view of your eye. Okay, and how does your eye sees the image of the object? Alright, this is actually how your eye sees the image of the object. Right, I'm going to align back to this line again, and I'm going to extend backwards. Same here, I'm going to align the ruler, and I'm going to extend the line backwards. And it is at this intersection, it's the image of object. So is what the eye sees is actually the image of the object immersed in the water, not the object itself. It sees the image, and that's why the image appears to be shallower than where the object is. Note I use the word appears. The image appears to be shallower, and I'll lead on to, because it appears to be shallower, the depth at which the image is what we call the apparent depth. This is what we call the apparent depth. So this is where the image is. Right? This is what we call the apparent depth. Okay? And where the object is what we call where the object is what we call the real depth. Right? It's the real depth. Okay, one is real, one is apparent. Hence you call it where the image appears to be. So that's another way to calculate refractive index of the medium. So in this case it's water. So the refractive index of water refers to the real depth over the apparent depth. And I won't write water, I'll just say refractive index of medium equals real depth over apparent depth. Alright, but all other refractive index still applies. It still applies in the sense that if I have this angle, I call it I, and this angle I call it R. So refractive index of the medium is actually also equals to sine I over sine R. Okay, refractive index is also equals to sine I over sine R. So this is what I'm trying to show you, how the eye sees the image of the object that's been immersed in water, and how the image appears to be shallower than the real depth of the container. Right? An object is actually much deeper than where the eye perceived the image to be.